Good afternoon. My name is Marco Russo. I'm from SQL BI. We produce content about DAX data modeling in Power BI analysis services. And the session for today is about aggregations in Power BI. So the goal of this session is to make you aware of what you can do with the aggregations in Power BI, what you cannot do with aggregations in Power BI. Just to get an idea about the audience, how many of you use DirectQuery? Okay, it's a wealthy audience, because what I say, DirectQuery is for the rich. And I will explain my sentence at the end of the session. However, the idea of today is to understand how we can improve the performances of a DirectQuery solution by using the aggregations, and when this is not really useful, and I will provide you a guidance about how to correctly set the aggregations in your model and how to check whether the aggregations are used or not, and how to solve a few modeling problems that could not use the aggregation if you don't design the model and the aggregation properly. At the end of the session, I will also show you how to use aggregations that are not supposed to work by just using DAX. And this will also enable you to use aggregations without DirectQuery, which is a problem that only people who have billions of rows probably face, because if you have just hundreds or tens of millions of rows, usually you don't need aggregations in import mode or in direct lake mode. So the aggregation, the idea of the aggregation in Power BI is to just improve the performances of the storage engine. When you run a query in DAX, what happens? The query, the DAX query or the MDX query if you use Excel, is evaluated by a first layer that is called the formula engine. The formula engine knows DAX, MDX, all the crazy functions that you write, including the new visual calculations. But at a certain point, this initial layer has to retrieve the data from the actual storage. If you imported the data, this storage is called Vertipack, which you see in the lower part of the slide. If you are using DirectQuery, the storage is your SQL Server, Oracle, MySQL, usually a relational database, or in the case of Direct Lake, the SQL endpoint of your Direct Lake that is providing the data extracted from the actual data source. Providing the data, which data? Well, the data that is already aggregated according to the request made by the formula engine. So the formula engine tries to minimize the effort required to the storage engine to retrieve the data on the fly. When you import the data, what happens is that the data is simply moved in memory in a compressed state, the Vertipack engine, which provides a response to these queries that aggregate data, usually in a very effective way. Okay, that's the idea of how the engine works. So I will use those slides mainly as a recap for those of you that will take a look at the slide. I will go back to the slides later, but what I want to do, I want to start from scratch. I start with a model, which is a simple model, which has a small amount of data. Because the reason is that the session is only 50 minutes, and usually I should use aggregations when one query that I run here takes 20, 30 seconds or minutes. But you can understand it if I would approach the way this way. First of all, I should have a lot of jokes to tell you when we wait for the answer, and I'm not so good at jokes. And second, we will not have enough time. So we will focus on trying to understand whether the aggregation is used or not, and you have to trust me that when you have a larger model, actually this also reduces the execution time of the query. So let's start with this model where we have a classic Contoso model where all the data, all the tables have been stored. Actually, I made a mistake, sorry. I have to remove these two tables That's the problem when you rehearse the session a few minutes before the session and you forget to clean up the model. Give me 1 second, but this is easy because these two tables are supposed to be added during the demo. So I have a few tables here: store, product, sales, date, and customer. So this is the classic Contoso model where we have data about sales, about products, customers, and so on. All these tables are not imported, they are connected in DirectQuery mode. How can we check that? Well, we can select a table and we can make sure that in the advanced mode, the storage mode is DirectQuery. Okay, so this is the initial starting point. All the tables are in DirectQuery mode. What does it mean? When I create a report, and we have here two simple matrices, one that shows the data by year and total quantity, and the other one that is year and, let me check, I don't remember which data we included here. We have the country, I think the country of the customer, if I remember well. Let's take a look. So this is what we have. Yes, we have this geography, which is the geography hierarchy of the customer, which includes a few columns of the customer. So basically we have, let's say, 2 dimensions, so customer and date, used to browse sales. Okay, so what happens when we refresh this report, or when we navigate this report? You might know that every time I do some click, something happens. And if we want to understand what is happening, we have a tool called Performance Analyzer that can monitor the DAX query that is executed when we do some drill down. So for example, now I drill down here, and you see that in matrix here we have this copy query and run in DAX query view. I'm interested in copy query because if I open the notepad, I want to show you, because then I will show you this in DAX Studio. So if I open the notepad and I show you what is included here, you see that there is a DAX query provided by Power BI, and after that there is the SQL query or the SQL queries that have been sent to the engine. There could be more than one. So potentially you already see what is the query that is sent to SQL. However, this is a relatively difficult way to understand what is going on. And so in order to understand better what is happening, we use an external tool called DAX Studio, this one, which is a tool that enables me to monitor what happens during the execution of query. So if I open DAX Studio, now DAX Studio is connected to the same model, Contoso DQ, that is connected in DirectQuery mode with my model, and I enable this server timings. Server timings is a feature that connects DAX Studio to the engine of Power BI Desktop in this case, and retrieve information about the execution from the profiler, and will show here what is going to happen. However, what can I do to see what is happening? Well, if I paste what I had in my clipboard, you see that we have several things. We have this part that is the DAX code, the initial part, and then we have the query in SQL. Now, I don't need a query in SQL. Usually DAX Studio asks you, now because I played around, it didn't ask me, but DAX Studio usually asks you whether you want to include only the DAX query when you copy and paste the query. Why I'm doing this? Because I want to execute only the DAX query and see what is the execution of the engine. This is important because by doing that, it's very clear now, and we can see at the bottom here, that we had 2 SQL queries that have been executed to satisfy a single DAX query. And if we take a look at these 2 queries, we can see that the first one retrieved the aggregation of the column quantity. The measure I used is a simple sum sales quantity, single column sum. And we have a join between sales and date because my report was showing the total by year. Let's check. What was my report doing? Look at that. We have the year to 2017, 2018, and so on until 2020. And then just for 2020, we have the list of the total quantity grouped by product brand. So the part of the query that shows the detail by brand required a second SQL query which groups by year, brand, and sum the quantity, joining the tables, sales, date, product, but it's important here, we have a where condition that actually filters only a few years that we want to see with the data at the level of detail that we need. Now, we actually drilled down only 2020, but I guess that because previously I also opened 2019, internally the visual knows that there is some data. Now, why am I showing you all these details? Because when you analyze a query, you see that the server timings shows you an important information, which is the division of the time between the formula engine, yellow, orange, depending on your monitor, your eye, and the storage engine, blue, azure, depending on your eye, your monitor, color could vary. But you see basically FE, formula engine, SE, storage engine. Now, the only thing that you can optimize with the aggregations is the storage engine, period. If your query in DirectQuery mode is running requiring 2 seconds and 100 milliseconds are storage engine and the rest of the time 1900 milliseconds are the formula engine, you don't have a problem you can solve with the aggregations. Fix your DAX code and improve the formula engine. The aggregation will not help you. Now, if we are in the space of the problem where we have a problem with the storage engine, Marco, we have to solve it, good, we can do something. What can we do? Well, the idea is that you know that you have 2 SQL queries that are slow. At this point, you can do 2 things. You call your database administrator, or you look yourself in the mirror if you are the administrator, and you ask for an improvement in the SQL Server database. You can add a materialized view, you can add something, but at the end of the day, you might reach a point where, well, actually, this query cannot be optimized further. We still have a query that is too slow. So what can we do to improve that query? Well, we can try to query a smaller table. So let's go back to the data model that we have in Power BI. In Power BI, we have this situation. So if you think for a moment, let's say that my query that is grouping the sum of the quantity by year is joining a table that has 100 million rows. Nice. If I have 100 million rows in SQL and the query, and the table is not using a column store index, or you're using MySQL, PostgreSQL, some other database that doesn't have the column store index or something like that, you might still create indexes, but actually a better solution could be, well, why we don't create something that reduces the size of the table we have to scan. So if instead of scanning 100 million rows table, we scan a smaller table, maybe with just 1 million rows, you know what? It's a 2 order of magnitude difference, it should be faster. So the idea is that, okay, what if I create in SQL a table that has a smaller number of rows because it pre-calculates, it pre-aggregates the sum of the quantity by, for example, date. I'm aggregating by year, but if I have the data aggregated by date without the details of the customer, of the product, I will obtain a smaller table. Okay? Now, let's start with this. So, and we keep this in SQL. Okay, I want to go step by step. We keep this table in SQL, and what can I do? Well, I can modify my model, and I import a table that, sorry, not this one. I import a table from SQL Server. I import a table from my database. I input here the server name and the database name, and I import this table in DirectQuery mode at the moment, and I click OK. So actually, I'm not importing. I'm just connecting the table in DirectQuery mode. And here, I prepare in advance this table sales by date. Here we go. So sales by date is a table that has a smaller number of columns and also a smaller number of rows because it doesn't have the detail of the customer, the detail of the product. So here we have the sum of the quantity for all the transactions happen in that date. One row per day. That's the idea. So the table is much smaller. You already see another column. At the moment, ignore sum line amount. Just focus on sum of quantity. And I import this table in the model. Let's go. Sorry, I'm continuing to say import. I just connect this table in the model because I'm using DirectQuery. I'm not copying any data at this point. And now I have the table in the model. What can I do? I can connect my order date column to date so that I will have the same relationship with the existing date table where I have the year, the month, and so on. Let's do that. So I connect the table this way. Remember, I'm still using DirectQuery mode. I just have to make sure that this should be a one-to-many cardinality because actually I want my date table to behave as a dimension, and this should be a single direction. So make sure that, especially when you have an aggregation that has a small number of columns, don't transform this aggregation in a one-to-one bidirectional relationship. That doesn't make any sense. And I click OK. Marco, what's the purpose of that? Well, if I can tell the engine, look, if you receive a query that only aggregates by year, instead of getting the data from sales, you could get the data from this table, because this table has the same information, but it has a smaller number of rows. And if you don't have a request that want to get the detail of the customer or an attribute of the product or the product brand, that's enough. You already have the same value. I could obtain a result in a faster way. And you can do that with the aggregations. What I'm going to do, I'm going to use manage aggregations to inform the engine of my will. So now with manage aggregations, I say, look, this table is the aggregation table, and sum of quantity contains the sum of the sales quantity column. So basically I'm saying I'm teaching the engine to intercept the storage engine query that could ask the sum of the quantity over the sales table and use this other table instead. That's it. I don't need to do anything else. If I do this and I apply all, what happens at this point? Well, you see that the table says by date now is hidden. Because the idea is the aggregation is not supposed to be used by the user. It's supposed to be used by the engine. So usually it's a hidden table. The user will continue to interact with the same report that it has. And at this point, if we go back to DAX Studio and we execute the same query again, and just to be sure, I clear the cache on run. So every time I clear the cache, I run the query again. And now what happens? Now we will see that we still have two SQL queries, but we notice a rewrite attempt. Because the model has aggregations, the engine tries to rewrite the original SQL query using a different version that should be more efficient based on our declaration. And let's see if this is true. First of all, the first attempt failed. What does it mean? Well, if you remember, there were two queries. One of the two queries is a query that actually uses sales, date, and product. But our aggregation only has the quantity and the date. And the year belongs to the date table. The problem is the brand. The brand belongs to a product table that is not part of our aggregation. So the aggregation we have is not compatible with this request, so this request is sent to the original table. But the second request now is sent to sales by date. It's the same query we have seen before, but the engine replaced sales with sales by date, which is the aggregation we prepared. So far, so good? If you have any question, just raise your hand. Don't be afraid. I'm used to manage questions. Okay? Question. Microphone or question. Thank you, so I can drink some water.
So I was connecting to this ag sales by date table. Is this materialized somewhere in the the SQL Server? Because otherwise, how is it benefiting for the performance?
It's an excellent question. So the question is, Marco, and this is exactly, thanks for the question, because this is exactly something I wanted to talk about. What we're doing now, we're working on the Power BI engine level, on the DAX engine side, teaching the engine what to do. Assuming that querying this table or view or whatever it is, I don't know, should be faster, okay? We are making the assumption that that object in SQL will behave faster than the original table because it is smaller, because blah, blah, blah. How do we guarantee that? That's your business if you want to use DirectQuery. Now, if you use SQL Server, a good way to implement that is to create a materialized view. Because a materialized view in SQL Server guarantees that that table is synchronized with the original sales table, but because it is stored in a smaller amount of memory, of pages, performances will be better. If you create a materialized view, or for example, another thing you could do, you could have a column store table, but actually that I don't think it works well for, I'm not an expert in SQL Server, so we enter here into the DBA. What is the best thing to do in SQL to do that? I don't know so well. I can tell you that you could have different approaches, but clearly if you're not using SQL Server and you're using, for example, MySQL, how do you guarantee that this table is faster than the original table? Because if you create a view, it doesn't work. A materialized view is another thing in SQL Server. I have no idea. It depends on your database. Then we will see what to do with import data. But remember, we have to ask ourselves, wait a minute. I would say 50% of the audience said, we use DirectQuery. The real question is why? There are two good reasons for using DirectQuery. One, real time. Two, too much data. For the problem number one, you cannot afford to process something, right? If the thing is you want real time, you want a materialized view. There is no other thing you can do. Because the alternative, that I will show you later, is what are you doing? I will show you this later. The second is, I have a lot of data. Okay, in that case, makes sense. But you have a lot of data, and you have to create probably another copy of the data somewhere, in any case. Okay? You say, Marco, but we have another case. Let's talk after the session, because probably it's not good for DirectQuery. But again, let me check what time it is. Marco, we want a single copy of the data. So no indexes, right? An index is a duplication. An index in SQL is a copy of the data. Don't make, a religious statement here, or a political. It's not a political thing, right? It's not a good reason to say I want a single copy of the data, because whenever you create an index, you are copying data, you're duplicating data. Period. Full stop. Back to the session. However, so this is the thing. So this is how it works. I'm teaching the engine what to do. Now, wait a minute. Now we still have another another query that has not been optimized. What can I do? Well, let's create another aggregation, right? If I want to optimize the second one, I can just create another table in SQL or another materialized view, whatever, that also include the customer. So, the product. Let me check, I don't remember. So demo and Contoso DQ and DirectQuery. So I repeat the same process and I choose customer and date, this one. So we want to get the customer and the date, right? Let's go. So if I get the customer and the date, now I have two columns, order date, customer key. I don't have the detail of the product, and I have the sum of the quantity. I now go a little bit faster because I repeat the same steps I did before. So now I have this new table. I connect this table to the customer through customer key, and I connect this table through one to many. Okay, I just check that everything is okay. Order date goes to date. Okay. So what I have now is this. This table is like sales. This table is like sales. It is just a table that is sales grouped by something. So now we have two different copies of sales from a logical point of view that we can teach the engine, well, look, this is another aggregation. So I can go here, manage aggregation, and say, look, sum of quantity is the sum of sales quantity. I try to do the minimal amount of effort to do that, okay? Now, pay attention. I'm not setting the precedence, because now, if you think for a moment, when I run a query, there are three different tables that should have the same data. How the engine can guess which one is better? It depends, right? We will introduce the precedence, but let's try out of the box what happens. Let's go back to our demo. So now, in reality, I don't expect this query to be faster because this query is using date and product, not customer. So if I try to execute this query, what happens? Nothing. The same thing that we have seen before. The first is an attempt failed because we introduced a table that has the customer, not the product. So this is not optimized, but the other query here, if you remember, this query has the year and the customer country. This one should be optimized. Let me try. So if I refresh this query, I copy the DAX query here. I paste the DAX code in DAX Studio. I want just the DAX part, and I run this query again. Now you see that we have the following. First of all, this query is way more complex. We still have two failed attempts. The reason is that the first one is just give me the first customer in Europe. It is, I don't know where it is used, but, oh no, sorry, it is just get one. It's just a check whether, is there some customer in Europe or not. But because we didn't provide enough information, it is not used. So the second one is another one that just get, is 2019 in the model or not? But these are small and simple query to execute. The one that have been optimized, you see, when you see match found, it means that the original query has been transformed. Indeed, if you remember, we are optimizing the queries over sales, not the queries over date or over customer. When sales is joined with customer and date, you see that now, instead of using sales, we are using sales by customer date. The engine is using this one. Okay? But remember, we had to create the tables, provide the tables, update these tables, define the aggregations. And just to optimize sum of quantity. What do we have in the real world? Sales amount. Maybe that you don't have a simple sum. You have this measure, which is written this way. I want to sum for each row in sales the multiplication of two columns. I have a formula in a measure that I want to optimize. What happens when I run this code here? Oh, I can try. I can run performance analyzer again. I can refresh just this matrix. I look at the query that I executed here. I paste the DAX code here. DAX query only. Let's take a look. You see that now these summarized columns is aggregating, sorry, is computing sales amount, the measured sales amount. And in order to in order to compute sales amount, we know that the calculation should use quantity and price. We only have, in the current aggregation, we only have the quantity. So if I try to run this query again, what happens? Let's take a look. You see we have two SQL queries. No rewrite attend, no anything. Why? Well, because now, you can see this here. there is the need of computing quantity by price row by row, and then the result of this query that you see here, the one that I'm highlighting now, which is this T0, this sum is summing the result of the internal subquery. And this cannot be optimized out of the box. Okay, Marco, what can we do? Oh, yeah, we have a way. We can go in sales and say, look, I know that this is the way I want to create my measure. I want to declare my measure with the calculation, with the business logic. But in order to enable the aggregation, I should, I should retrieve this formula, this multiplication, and I have to move this multiplication into a calculated column. So if I look at the hidden columns, I prepared a line amount column. Why a calculated column? If you are using DirectQuery, a calculated column is not materialized. A calculated column is computed on the fly. And I'm declaring in the semantic model that this multiplication should be made at query time. This is a characteristic only of DirectQuery. If I do that, and I transform my sales amount into a sum of one column, then now I can use the aggregation. How? I go back to my aggregation. If you remember, we had two columns, sum quantity and sum line amount. I just have to say, look, this is the sum of sales line amount. Apply to all. Same here. Oh, one thing that I forgot, and I should have mentioned before, when we have two possible aggregations, the engine might not be smart enough to understand which one is better. Because if we aggregate just grouping by date, there are two aggregations that are equally valid. So if we want to say, look, in case of a conflict, in case that these two aggregations are equally valid, this one should have precedence 10, for example, because we have more rows, and the other one, the one that I had before, should have preference, should have a precedence, for example, 20. So the higher the value, the higher the priority, which means that as soon as the engine scans the aggregation starting from the highest value, and as soon as it finds an aggregation that matches the request, it uses that one. So usually I will use the aggregations that have a lower amount of rows with a higher priority so that I can improve the performance for choosing the less expensive aggregation. Now, by doing this, did I solve the problem here? Absolutely no. I'm still using sales amount. As long as I use sales amount, which is not used in the calculate column, this is not optimized. If I look at the query generated now, you will see the same SQL queries without any aggregation used. What I have to do, I have to use sales amount 2. I just change this here, just to run this faster. And if I do this, now you see that my aggregations have been used. Okay? This one failed because, again, this one is using probably the brand that is in product, and product brand is not included in the aggregation. But the second one is using an aggregation because we are using, at this point, the sum of line amount. Make sense so far? Questions? Let me recap with the slides, 1 second, what we have seen so far. So with the configuration, we can describe what to use, what are the columns that we can aggregate. The aggregation we can use are sum, count, min, max. Stop. Marco, we have an average. Okay, you're lucky because an average is the division between the sum and the count. But there could be other aggregation that will not be optimized, of course. In reality, we have a chance with distinct count. Because if we have a calculation that involves a distinct count, well, we can do something. Let me show you. I have here customers. the number of customers that you see here, let's take a look at the measure. The number of customers is the distinct count of sales customer key. How many unique customers did we have in each year, or in each year and country, and so on. Now, this measure is not, let's say, is not computed using the aggregation because I didn't provide enough information to the engine to understand that the distinct count could be made not on sales, but on the aggregation. How? Well, the idea is that if I just have to go, first of all, let's make sure that this is that what I'm saying is true. So let's go back to Performance Analyzer, start recording. I refresh this visual. I go to the matrix. I copy the query. I go in DAX Studio. I paste the query, DAX query only, run the query. I'm going relatively fast, but you can always check whether the result that you obtain is actually the underlying result that is used by the visual. And in server timings, we see every attempt has failed. Failed, failed, failed. What does it mean? You have this. Count, distinct, sales. You see sales. You have 100 million rows. This is slow. What can we do? Well, we can say, look, this model has, in this table, manage aggregations, the order date is grouped by sales order date. Actually, this is not customer. I should have started from this other aggregation. Manage aggregation, customer key, grouped by sales customer key. I'm informing the engine that the column customer key in this table is grouping the column customer key in sales, which means that a distinct count on sales customer key could be transformed into a distinct count here. Let's try. I go back to DAX Studio, I run the same query again, and here we go. Now we have match found, match found. At least in these two cases, the first one no, because it is still asking data for the product. So far, so good? So, back to the slides. These are the aggregation we have available. This is just a sort of documentation you have in the material that you can download later. We have seen that if we have a calculation at the row level, we have to change the model and store this information into a calculated column so that we can actually match the corresponding result with a simple aggregation for a single column. And once we do that, we have been able to solve the problem. So this is the first the first change I made. Use line amount column to do the aggregation. Distinct count, I used group by. And so the group by is what allowed me to obtain the result. But now, let's talk about the storage mode. So far, I only used DirectQuery. I only use SQL because I assume that we are in the first use case that you should have to justify DirectQuery, which is expensive, which is real time. Or we absolutely need real time. And if you need real time, you need to use SQL, period, full stop. If you have a large amount of data, though, this technique can be still too slow. So you want to import some data, but because you import data in memory, you have a limited memory. But if I import a smaller table, for example, if my aggregations are smaller tables, I could import those tables in memory, and I could increase the speed of my query a lot. However, if I import the data, guess what? I will face the problem of the inconsistency of the data if I have a real-time system. You cannot use Vertipack import if you have real-time. That's the reality. Because otherwise, you don't have a good reason for using DirectQuery. Now, if you have this large amount of data and you want to improve the performance, let's see what we can do. I can say, look, this table is no longer DirectQuery. You see here, instead of DirectQuery, I choose import. I import the aggregation. At this point, for technical reasons that I don't want to spend too much time now, the tables that are connected to this aggregation table must be moved in import mode too, because otherwise it will not work. But of course, we want to continue to use in this case, the date table in DirectQuery mode when we use sales, in import mode when we use the aggregation. The storage mode is automatically changed to dual, which means that this table is both. This table can work in both modes. And now you see that when I do that, the table ag sales by date has been imported in memory, now is in memory, and the table date now is imported in memory too, but when I use DirectQuery only, it will be joined with the original table there. Same for the other. So we go here, manage aggregation, and storage mode, import. Okay. Recap. Sales is DirectQuery. Ag sales by customer is in memory, import. Sales by date is import. Okay? Customer and date are dual mode. What happens at this point? I run the last query again. Run. Now, when the match is possible, you see match found, the query is no longer SQL. When you see scan, we are scanning the in-memory Vertipack engine. And the query that is executed seems SQL, but it is not. This is XM SQL. You see decount doesn't exist. You don't see group by. So it's very similar to SQL, but it's not SQL. Usually this is much faster. But do you want to use this in a real time? No. Let me show you what could happen. Look at the data now. Let's go back to this one, sales quantity. For some reason, in the relational database, something changes. And in order to simulate that, now I'm removing from the database, I'm removing the data for 2017, okay? Now, I made a trick and I removed 2017 from the relational database. However, I didn't refresh my data. It's the same thing. There is a new transaction in DirectQuery, but I'm not updating in real time my imported aggregations. What happens? Well, it's a mess. Because now, if you refresh everything, something bad could happen. For example, if I just refresh, so if I refresh the entire model, I will retrieve, and I will refresh also the aggregation. If I don't refresh the aggregation, but the user starts to navigate the model, you might have some strange behavior for which when I drill down, for example, here, you see that 2017 is visible. Let me think. This is a query. I'm thinking this is customer. Okay, I have to use the product. So if instead of using the customer, which is in the aggregation, I use the product, for example, here, I use the product brand. And so I just have to change this one. So let's remove the geography, and let's use the product brand here. Now, you see that if I try to drill down 2017, I don't see anything. What is happening here? The query that retrieves the data at the year level, see 2017. The query that tries to see the data at the level of the product, don't see 2017. You might start to see numbers that don't match. Don't do that, right? The only reason why we use this system is because we want to see good numbers, not bad numbers. Yes, the query is faster, but it's wrong. And so this means that I can, let's say, use this system only for the second case. I import the aggregation when I cannot load in memory, I cannot import, for some reason, the entire database. Okay? That's a good use case. But if you think about what we have seen so far, what is a common use case that we could have? If you think for a moment, most of the databases have a large number of rows because you want to keep a particular level of detail in your sales table. Oh, yeah. I mean, sorry. Let's go here. Here. My sales table has, let's say, 500 million rows, which is not a huge number. But I keep order number, notes, a lot of information I never use in my aggregation. At that point, I would like to say, well, okay, I want to keep this table in DirectQuery mode because when I want to go at the level of the single order, I want to see everything. But whenever I navigate at a higher level, I want to use a table in memory because it is faster. Without the constraints that I would have in creating the aggregation like we have seen before, every call, you have to transform every column, every calculation, and so on. Can you do that? No. We don't have a way to say, use this table in memory when you have an aggregation, and use the other table only when the user goes down at the order level. I would like to go in memory, because I can afford it, 200 million rows in memory. It's not a problem. But as soon as you go into a single order, I want to go DirectQuery. You don't have a way to do that. I mean, you could try, but you will find that it is not easy. The effort required is huge, and you don't get exactly the flexibility that you would like. Unless you say, well, but you know what? We can use DAX. I can write this code. I can write a measure that says, and of course, you have to write this code in all the measures, I know. And I can say, if the user is filtering by order number, go to some sales line amount. Otherwise, sum this other table. I am in control of which table will be used. And I have no constraints if I use this technique. The advantage of this technique, you can use this technique to create an aggregation that works over Vertibac. If you have billions of rows imported in memory, you can. Any query is still not so fast, but you could always say, okay, I go in a few 100 million rows when I have the aggregation. Otherwise, I go to the other table. Am I using the aggregation of the engine? No, I'm just using tables and controlling this in DAX. And this can work in any kind of aggregation. I'm not suggesting you to use this one. I'm saying, look, when you are out of options, this could be something that you could consider. Okay? Trying to hijack the calculation using different tables depending on the level of granularity so that you use the table that is more efficient. Marco, but we have automatic aggregations in Power BI. They are created automatically. Yes, of course, but they have the same constraints, the same features, and the same limitations that we have seen so far. Work on a single column, priority, and so on. And they have to be materialized. And again, if you are working real time, you cannot use automatic aggregations in real time. Think about this. You will have the consistency issue the same. So aggregations are good for single columns aggregations. You have more complex calculations, you have to revert them to a calculated column so that you can enable the aggregation. Otherwise, you're in trouble. The aggregations have to be designed by yourself. Then you can decide to import them, but otherwise should be stored in SQL or should be visible in SQL in some way that is faster compared to accessing to the base table. Group by is the way to identify columns that you want to use in distinct column. And just a quick reminder, the automatic aggregation are just a way to automate the process of creating the aggregation that you need, but you still have the same constraints that we have seen. That's the reason when I say direct queries for the rich, it's expensive. It's way more expensive than importing the data. That's my point. So when I see we have direct query because, okay, but do you have a good reason? Because the real time doesn't allow you to use many aggregations. That's the point. And that, in my experience, the real time problem is the more common reason. However, if you use real time, I don't know if you can use aggregations efficiently. If you have a lot of data, aggregation are, of course, a very, very efficient way to control what is happening. I think that we're out of time. Thank you for attending. Remember, vote, provide the feedback for the session, provide votes. There is a daily prize draw. I am available for your question just outside here because I have to probably leave for the next session. Thank you very much.